Okay, so now I'm explaining how to do the homework, all right? And so what you're going to do is you're going to write what I'm writing, you're going to write above here like this. All right, I'm going to show you with problem number 1 and problem number 2, and you're going to write above here. What I'm writing, you're going to put up here. But I've already done it, so I'm going to move this up so you don't see it, and then we're going to do number 1 and 2 together, all right? Okay. All right, here we go. Okay. So no, it doesn't give you the molar mass. Instead, it gives you something else, and you have to convert the units that you're given into the molar mass. It's not any big deal. You just have to convert your units. So let's look at number 1. And then I'm actually going to do number 1 for you. All right? Okay, so number 1. The units of molar mass here that are given are 1.96 grams. All right. So 1.96 grams over 1.0 dm cubed, decimeters cubed. Now, the one thing you need to do for this, you're trying to get to grams per mole, because grams per mole are the units of molar mass. So that's what we want, right? The one thing that would be helpful here is that 1 decimeter cubed is equal to 1 liter. Oh, that's super helpful. That is super helpful. I know that. I'm telling you. Right. And the other thing that's super helpful is that this is a gas. All of these are gases. So that's super helpful. So now what we're going to do is we're going to go 1 decimeter cubed is equal to 1 liter. And then 22.4 liters is equal to 1 mole. And so now I can cancel this, and I'm left with grams per mole, and there's my molar mass. Well, there's one other one because not all of them are in decimeters cubed. Yeah, Holland. Why would you do that? So if you flipped this, you would end up with moles per gram. Right? Does that make sense? So it would end up wrong, wrong. You would end up with 1 over your molar mass. So that wouldn't work. Okay. So that's how you would do this, all right? And now let's look at number 2. So in number 2, you're given 1.72 grams over centimeter 500 centimeter cubed. 1 centimeters cubed is equal to, does anybody remember something? Oh, Aaron, good work. 1 milliliter. And that is super helpful because from 1 milliliter we can get to liters. So 1 centimeters cubed, 1 milliliter, and then milliliter, 10 to the minus 3 liters, and then 22.4 liters, 1 mole. Equals, and then again, grams per mole. So there we are. Once again, we're into molar mass, right? Okay, so centimeters cubed, milliliters, liters, and there we are, moles and grams. Okay? Kind of cool. A little bit of magic. All right, now let's look at number 3. Number 3, they don't even give us units, so we're not doing that. It's 17. It's actually grams per, I think it's grams per liter, but we're not paying any attention to that. Next. Okay, next one. So here we have grams per milliliter. We can do that, right? Because I just gave you grams per milliliter right here, right? So you can do that one now, yeah? And the next one, number 5, is grams per centimeter cubed. You can do that one now, right? It's right here, grams per centimeter cubed. And then the next one is grams per milliliter. You can do that one now too, all right? So you must find the molar mass before you do these. Everybody with me? Okay? All right, let's do number 1 together. Okay? We're going to start from scratch.
If it's like C6H6, for example, would that just become CH?
No, because that would, if it's C6H6, that's the molecular formula. If it's CH, that's the empirical formula. All right, here we go. So I'm going to, first I'm going to calculate my molar mass. All right? So I'm going to multiply across the top, and then I'm going to divide out the bottom, right? And when I do this, I get 43.9 grams per mole. That makes sense? So that sounds correct. 1.96 grams per mole does not sound like something I can use for my molar mass. But 43.9, that does sound like a molar mass. Does that make sense? Because remember, I have to divide my molar mass by my empirical mass. So 1.96 is not something I can divide by an empirical mass. No, that does not work. So now let's take a look at running the calculations on the problem itself. So 27.3 grams of carbon, 12.01 grams of carbon to 1 mole. And then 72.7 grams of oxygen, okay, so okay, so my empirical formula is CO2. My empirical mass, 1 carbon and 2 oxygens, so 12.01 and 32, 44.01. So the next thing I'm going to do is I'm going to take my molar mass, which I calculated as 43.9, and I'm going to divide that by 44.01, and that equals approximately, good enough for government work, 1. So, right, so that means that CO2 is my molecular formula. Yep. Okay, if it was a 2, then it would be a 2, right? You know, then I would multiply C2O4, right? But it's not, it's 1, so I'm good to go, all right? Okay, so you have to make sure that you find out your molar mass before you get started. Okay?